Hi guys, today we are learning how to model and solve one-step equations using multiplication and division. We are going to quickly review what we learned yesterday. The goal in solving one-step equations is to get the variable alone or isolate the variable. To do this, you need to use the inverse operation. So below, we are going to state the inverse operations. Add 23. The opposite of adding 23 is to subtract 23. The opposite of subtracting 18 is adding 18. The opposite of multiplying by 15 is dividing by 15. And the opposite of dividing by 8 is to multiply by 8. So how do you model solving equations that contain multiplication or division? I want you to pause this video lesson to complete page 335 in Go Math on your own. When we solved the equation 3x equals 12, we found that 4 tiles were in each group. So 4 eggs are needed per batch of cookies. Let's use the same strategy from our Go Math page to model the following problems. We have the problem 2x equals 6. If we solve that using a model, the 2 cups on the left represent 2x. The 6 dots on the right represent our 6 holes as our answer. If we break apart the 6 into 2 equal groups, each cup, or x, has 3 dots in it. So x equals 3. If we plug in 3 for x, we find that both sides of the equation have the same value. 6 equals 6, so we solved it correctly. Why is the solution to the equation the number in each group? This is because we have to divide the inverse operation of multiplication to solve for the variable. Let's solve some guided practice problems together by using modeling. Our first equation is 3x equals 6. So I am going to put 3 x's on the left and 6 dots on the right. Down below, I'm going to make sure I put my 6 dots into 3 equal groups. So I'll put my 3 x's on the left And if I want there to be equal groups, I will put 2 dots next to each x. Next, we can circle those groupings to see that there are 2 dots for each x, so x equals 2. Next, let's solve the equation 4x equals 12. On the left, I'm going to put 4 x's. And on the right, I'm going to put 12 dots. In the next boxes down below, I'm still going to put my 4 x's. But this time on the right, I am going to put my 12 dots in 4 equal groups. Next, we can circle those groups. And we find that there are 3 dots for every x. So x equals 3. The last equation we're going to solve together is 2x equals 10. So I'll put my 2 x's on the left, and I'll put 10 dots on the right. In the next boxes down below, I'll still put my 2 x's, and I want to make sure I have 2 equal groups for my 10 dots. We can circle the groupings. And we find that there are 5 dots for every x, so x equals 5. Remember that when we are solving equations, we always want to use the inverse operation to get our variable by itself. So when solving an equation that contains multiplication, we will solve by dividing both sides of the equation by the same non-zero number. In our example on the right, we see 2 different equations. The first one, 9a equals 54. Notice that 9 is multiplied by a. So in order to get a by itself, we would use our inverse operation and divide both sides of the equation by 9. So when we do, we see that a equals 6. We want to check our answer and put it into our original equation to make sure that both sides of the equation have the same amount. So if we plug in 6 for a, 9 times 6 is 54, which equals 54 on the other side of our equation, so we know we solved it correctly. Our next equation is 18 equals -3 times d. -3 is multiplied by d, so we would want to use the inverse operation of multiplication, which is division. So we will divide both sides of our equation by -3 to get d by itself. When we do, we find that d equals -6. To check, we'll plug in -6 for d, and when we multiply -3 times -6, we get positive 18. 18 equals 18, so we know we solved this equation correctly. Here is another example of a multiplication equation. we see 3 times n equals 12. We would divide both sides of our equation by 3 to get n by itself. So 3 divided by 3 is 1, so n now has a value of 1, or just n. 12 divided by 3 is 4, so n equals 4 in this equation. Now let's try some guided practice problems together. We see 7x equals 21. 7 is multiplied by x, so the opposite operation is to divide by 7. So I am dividing both sides of my equation by 7. We have to do the same thing to both sides to get x by itself. So the two 7s cancel each other out, and we're left with just x on the left. 21 divided by 7 is 3, so x equals 3. Next, we want to check and plug 3 into our original equation for x to make sure that we solved it correctly. So 7 times 3 for x equals 21. 7 times 3 is 21, so we know we solved this correctly. Our next equation is negative 18 equals 9m. Remember that variables can be more than just x. It can be any letter of the alphabet. So we see 9 times m, so the opposite operation is to divide by 9. We'll divide both sides of our equation by 9. These two 9s will cancel each other out and become 1. So we're left with just m on the right, and then on the left, negative 18 divided by 9 is negative 2. So m equals negative 2. Next, we will plug negative 2 in for m in our equation. Negative 18 equals 9 times negative 2. 9 times negative 2 is negative 18, so we know we solved this correctly. When solving an equation that contains division, we will solve by multiplying both sides of the equation by the same non-zero number. So on the right, we have a few examples. Our first equation, we see x divided by 5 equals 10. X is divided by 5, so the opposite operation, or inverse operation, is to multiply by that same number. So we will multiply both sides of our equation by 5. The two 5s cancel out and leaves x by itself, and 5 times 10 is 50, so x equals 50. Next, they plugged in 50 for x in the original equation. 50 divided by 5 is 10, so the equation was solved correctly. The second equation is 15 equals r divided by 2. R is divided by 2, so the opposite operation would be to multiply by 2. So we'll multiply both sides of our equation by 2. The 2's cancel out and leave r by itself, and 2 times 15 is 30, so r equals 30. We'll plug in 30 for r into our original equation. 30 divided by 2 is 15, so we solved our equation correctly. Here is another example of an equation with division. We see k divided by 2 equals 16. K is divided by 2, so the opposite operation is to multiply by 2. So both sides of the equation were multiplied by 2. The 2's cancel out and leave k by itself. K is now 1k, or just k. 16 times 2 is 32, so k equals 32 in this equation. Now let's try some guided practice problems together. We see the equation h divided by 3 equals 7. The opposite operation of dividing by 3 would be to multiply by 3. So we'll multiply both sides of our equation by 3. The 3's cancel out and leave h by itself. 7 times 3 is 21, so h equals 21. Next, we would want to plug in 21 for h into our original equation to check to see if it's correct. 21 divided by 3 is 7, and 7 equals 7, so we know we solved this correctly. Our next equation is k divided by 5 equals 4. The opposite of dividing by 5 is multiplying by 5. So we'll multiply both sides of our equation by 5. The 5's cancel out and leave k by itself on the left, and 4 times 5 is 20. So k equals 20. Next, we'll plug in 20 for k into our original equation. 20 divided by 5 is 4. 4 equals 4, so we know we solved this correctly. Sometimes when we're solving for the variable in an equation, we will have fractions instead of whole numbers. So to solve a multiplication or division equation that contains fractions, we will use the multiplicative inverse or the reciprocal. So let's start by finding the multiplicative inverse or reciprocal of these fractions. The reciprocal of 1/3 is 3 over 1. Remember, we just flip the numerator and the denominator around. So the reciprocal of 5/7 is 7/5. And the reciprocal of 2/5 is 5 over 2. Now let's use multiplicative inverses to solve equations. Down below we see on the left 3/5 times t equals 6. So we would want to find the reciprocal of 3/5 because that is the coefficient next to t. So the reciprocal of 3/5 is 5/3. So we would want to multiply by that reciprocal on both sides of our equation. So in the boxes down below, we will multiply both sides by 5/3. The 5/3 times 3/5 on the left will cancel each other out. They become 1. So t is by itself. On the right, we need to solve using the fraction. So remember to turn a whole number into a fraction. We just put that number over 1. And then to multiply these fractions, we just multiply across. So 6 times 5 is 30. And 1 times 3 is 3. So t equals 30 over 3. Next, we would want to simplify our fraction. So 30 over 3 is equal to 10 wholes. So t equals 10. On the right, we see the equation 2/7 times t equals 8. So we would want to find the reciprocal of 2/7 and multiply both sides of our equation by the reciprocal. So the reciprocal of 2/7 is 7 over 2. So we'll multiply both sides of our equation by 7 over 2. 7 over 2 times 2/7 on the left cancels each other out, so t is by itself. And to make our whole number on the right, 8, into a fraction, we will put that over 1. and then we will multiply across. So 8 times 7 is 56. 1 times 2 is 2. And our last step would be to simplify our answer. So 56 over 2 is equal to 28 over 1 when we divide both numbers by 2. And that is equal to 28 wholes. So T equals 28. Now let's try some guided practice problems together. For the equation on the left, we see 1/7 times t equals 3. Since we have a fraction on the left next to t, we would want to find the reciprocal of that fraction to multiply on both sides of our equation. So the reciprocal of 1 over 7 is 7 over 1. We just flip our numerator and denominator. So we'll also multiply the right-hand side by 7 over 1. T is now by itself. I need to put my whole number over 1. 3 is now over 1 to turn that into a fraction, and I can multiply across. 3 times 7 is 21. 1 times 1 is 1. So T is equal to 21 over 1, which is equal to 21 wholes. Next, we would want to check our answer and plug it into our original equation. So 1/7 times 21 is equal to 3. We'd put 21 over 1 to turn it into a fraction, and we would multiply across. So 1 times 21 is 21, and 7 times 1 is 7. 21 over 7 is equal to 3. When we simplify that fraction, we do find that it is equal to 3. 3 equals 3, so we know we solved it correctly. In our second equation on the right, we see 8 equals 4/5 times k. I would want to find the reciprocal of 4/5 to multiply on both sides of my equation. The reciprocal of 4/5 is 5 over 4. Five over 4 times 4/5 cancels each other out on the right, so we're left with just k. On the left, I would want to put my whole number over 1 to turn it into a fraction, and then multiply across. 5 times 8 is 40, and 4 times 1 is 4. So k equals 40 over 4. If we were to simplify this fraction, we would find that k equals 10. So next we'll plug in 10 for k into our original equation. 8 equals 4/5 times 10. I would want to put my whole number over 1 to turn it into a fraction so we can multiply across on the right. 4 times 10 is 40, and 5 times 1 is 5. If we were to simplify 40 over 5, we would find that it is equal to 8, because 5 can go into 48 times. 8 equals 8, so we know we solved our equation correctly. Now you will complete 2 independent practices on your own. The first one is equation practice. The second one is a math lib that you will find the answer to. Remember to ask questions if you need help, as this is still a new concept for us.